Hey everyone, and welcome to another explainer. Today, we're taking a pretty complex tech concept and making it crystal clear. We are unpacking Apache Kafka, which is basically the invisible engine running behind the scenes of almost every major app on your phone right now.
So you might be wondering, how do companies actually process millions of events per second without crashing? Whether you're calling an Uber, making a bank transaction, or buying something during a massive Black Friday rush, the answer, more often than not, is Apache Kafka. Because nowadays, when we interact with the digital world, we absolutely expect instantaneous responses. We want our ride status updated by the second, and we want our bank balance to be perfectly accurate the very millisecond we swipe our card. Kafka is the underlying machinery that actually makes all of that possible. I love this quote from the Apache documentation. They say, "Event streaming is the digital equivalent of the human body's central nervous system." And honestly, that brilliantly illustrates exactly why Kafka is so vital. Just like your body doesn't wait until the end of the day to process that you touched a hot stove, modern applications can no longer afford to wait to process critical data. Kafka connects and routes this data continuously, ensuring the right information gets to exactly the right place instantly. To wrap our heads around this, we're going to use a zoom-out approach today. On our agenda, first, we'll look at the event streaming revolution. Then, we'll dive into Kafka's core architecture, followed by scaling with partitions, and a showdown between Kafka and traditional buses. After that, we'll look at the broader real-time ecosystem, and finally, getting started with Kafka. Okay, let's jump right into Section 1, the event streaming revolution, moving beyond static batch processing.
To really appreciate what Kafka does, we have to look back at the pain points of the past. 10 or 15 years ago, businesses ran primarily on nightly batch jobs. You do your daily operations, and then, at 2 a.m., the databases would finally sync up and give you a report the next morning. But today, Kafka powers real-world use cases by publishing, storing, and processing continuous streams of data as it happens. We're talking financial transactions and fraud detection, live GPS fleet tracking and logistics, continuous e-commerce order processing, and log aggregation and metrics monitoring. You aren't just moving data anymore, you're reacting to it the very millisecond it's created. Moving on to Section 2, Kafka's core architecture, the fundamental building blocks.
Let's define the core vocabulary here, starting with a topic. A topic is basically a durable category or channel where events are stored. It's similar to a database table, but without all the rigid constraints. You can think of it like named channels, like orders or payments, where data flows in and is durably stored. But that word durable is absolutely crucial here. Kafka doesn't just hold messages in volatile memory. It writes them directly to disk. And that architectural choice is a massive game changer for sure.
Next up, we have producers and consumers. Producers publish messages to a Kafka topic, while consumers subscribe to read and process those messages. So a web app might act as a producer pushing data in, and an analytics engine acts as a consumer pulling that data out at its own pace. The real genius here is that they are entirely decoupled. If your analytics engine crashes, your web app doesn't even blink. It just keeps firing events into Kafka. When the consumer comes back online, it just picks up right where it left off. Let's dive into Section 3, scaling with partitions, breaking down the data for massive throughput. Okay, if we have millions of messages, how does Kafka not just completely choke? Let's track a fleet. Imagine a car's GPS topic that is capturing the live coordinates of thousands of vehicles, getting updates every 20 seconds. If you throw all that geographic data at one single server, it's going to crash under the weight of those concurrent connections. Kafka solves this elegantly through partitions. Topics are split into partitions across multiple brokers, which are basically just servers. It uses append-only logs to add new events to the end of the chain. This allows consumer groups to read those partitions in parallel. And what's really cool is that offsets act as bookmarks to track consumer progress, so it always remembers where it left off if a failure occurs. Finally, replicas ensure that your data survives even if an entire broker goes down. Because of this totally brilliant distributed architecture, Kafka can process millions of messages with sub-10 millisecond latency. Under 10 milliseconds. That tiny window of time is literally what allows live machine learning models to analyze behavior and block credit card fraud before the bank even finalizes the payment. Which brings us to Section 4, Kafka versus traditional buses, the showdown with legacy systems.
When we compare them, traditional message buses, like Azure Service Bus, generally delete a message once it's consumed. Their scalability is limited by broker sessions, and they rely heavily on in-memory or short-term queues. Apache Kafka, on the other hand, retains messages on disk for replay. It scales linearly via those partitions we just talked about and uses consumer-managed offsets. The fact that Kafka durably stores data on disk gives developers an absolute superpower: time travel. If you deploy buggy code that corrupts your data, with a traditional bus, that original data is gone. With Kafka, you can fix your code, reset your offset, and replay all that data as if the bug never even happened.
All right, let's zoom out for Section 5, the real-time ecosystem, where Kafka fits in the big picture.
You see, Kafka rarely works in isolation. It's really the bulletproof ingestion layer of a massive 5-part pipeline. Layer 1 is your sources, like apps, databases, and IoT devices, which generate the events. Layer 2 is ingestion, which is where Apache Kafka collects and orders that data. Layer 3 is processing, where tools like Apache Flink transform and aggregate everything. Layer 4 is storage, landing the data for queries in systems like Apache Iceberg. And finally, Layer 5 is serving, where tools like ClickHouse or Druid handle the real-time analytics for your dashboards.
But I do have a quick word of caution for you here: the real-time tax. Remember, streaming compute can cost up to 24 times more than batch processing. Use it wisely. Real-time streaming is a major investment, so you really need to ensure your specific use case actually demands sub-second latency. If a daily batch report works perfectly fine for your stakeholders, stick to batch processing. Don't pay the real-time tax if you don't have to.
And finally, Section 6, getting started with Kafka, bringing it to life with code. Writing code for Kafka might sound super intimidating, but in a language like Java, it essentially boils down to 4 logical steps. Step 1, you create your producer properties, defining the broker IP and serializers. Step 2, you create the producer itself by initializing it with those properties. Step 3, you create the producer record, specifying the exact topic and message. And Step 4, you send the data. But here is a massive pro tip: always execute the flush and close methods after you send. It is basically a rite of passage to forget the flush method and sit there pulling your hair out wondering why your data isn't moving.
Also, local testing is easier now than it has literally ever been. It used to be a huge headache, but with modern Kafka versions utilizing Craft instead of Zookeeper, you can spin up a local cluster using Docker and the Confluent CLI in seconds. You literally just run Confluent local Kafka start. Then, Confluent local Kafka topic create my_topic and Confluent local Kafka topic produce my_topic. It is that simple to start testing your pipelines locally.
So, after exploring all this incredible power, I want to leave you with a question. What parts of your own architecture are stuck in the past, and could they be modernized with Kafka? Take a hard look at your systems and ask yourself if you're ready to build a true digital central nervous system. Thanks so much for joining me on this explainer today. Keep building, keep learning, and I'll catch you in the next one.